What if our entire universe, all the galaxies, stars, planets, and life, is just a speck in an ocean of other universes? This is the bold premise behind multiverse theory, an idea that has captivated physicists, philosophers, and sci-fi fans alike. But is it science or speculation? In this segment of Infinity Beyond, we dive deep into the multiverse dilemma, exploring its origins, implications, and the controversy surrounding it. Let's begin with why this theory emerged. Modern cosmology paints a detailed picture of how our universe began. The Big Bang gave birth to space, time, matter, and energy. But our understanding doesn't stop there. In some versions of inflation theory, the expansion of space didn't end everywhere at once. Instead, it continued eternally in different regions, creating what's known as eternal inflation. Each bubble that stops inflating becomes a separate universe. Ours is one such bubble. In this view, the multiverse is not a metaphor. It's a literal, sprawling foam of universes, each potentially governed by its own physical laws, constants, and dimensions. Now, what makes this concept compelling is how it helps solve deep puzzles in physics. For example, why do the fundamental constants of our universe seem so fine-tuned for life? If there are countless universes with random parameters, then it's no surprise that one of them, ours, has the right conditions for observers. This is a natural partner to the anthropic principle. It also dovetails with string theory, which suggests a vast landscape of possible vacuum states, each corresponding to a different universe. Some even argue that the multiverse helps explain quantum mechanics. The many worlds. Interpretation of quantum physics proposes that every time a quantum event happens, like a particle being in two states, it splits into separate realities where each outcome occurs. This leads to an infinite branching of universes. In one, you chose vanilla ice cream. In another, chocolate. In a third, you never left home. But as fascinating as this sounds, the multiverse raises major concerns. First and foremost, can it be tested? Science relies on falsifiability, the idea that a theory must be testable and disprovable to be scientific. And here's the problem. Other universes, by definition, may be causally disconnected from ours. We can't observe them, send signals, or interact with them. This places the multiverse on shaky ground. Some physicists argue it's not science, but philosophy cloaked in math. However, others push back. They suggest that if multiverse models arise naturally from well-tested theories, like inflation or string theory, then we should take their consequences seriously. Think of it like black holes. For decades, they were mathematical predictions with no direct evidence. Yet we accepted their plausibility. And now we photographed one. Could the same happen with the multiverse? Maybe, but it would require indirect evidence, like patterns in the cosmic microwave background or anomalies in the structure of space-time. Some models suggest that collisions between universes might leave scars on our observable universe. Detecting such features would be a breakthrough. But so far, no smoking gun. And yet, the idea persists. Why? Because it offers answers. It explains the fine-tuning problem, provides a framework for quantum uncertainty, and expands our view of reality from one universe to a multiverse of possibilities. It also forces us to rethink what it means to exist. If every possible outcome happens in some universe, then identity, decision, and causality take on new meanings. You might exist in billions of forms: heroic, mundane, tragic, transcendent. And our universe? Just one page in an infinite library. That's either exhilarating or deeply unsettling. Critics argue that the multiverse is too convenient, that it dilutes the value of scientific prediction, that it's an escape hatch for unsolved problems. But proponents counter. that reality isn't obligated to be simple or satisfying. If nature is stranger than we imagined, we must follow the math, the logic, and the implications, even if they lead to places we can't yet reach. Ultimately, the multiverse might remain unprovable, at least for now, but it reshapes the questions we ask. Not just why this universe, but why any universe at all? Not what caused us, but what limits the possibilities of existence? We may never reach the edge of the multiverse, but the journey to understand it is expanding the frontiers of science, philosophy, and imagination alike.